All right, welcome back. And in this lecture, we're going to move on a little bit from our previous lecture where we talked about the result type and its bind function and bind operator, which I show on the screen here. And this is our script file that we began with. And the first thing we're going to do is we're going to move this over and start constructing our actual library, which is this result.fs file. If you didn't create this before, you can simply right-click, add new item, and add an F-sharp type. We'll do that. Add new item. You'll want to select a source file and call it result.fs. And that result.fs, if you use the one that came with the module, will probably have this in it. When we created the library, we added this namespace up here, but it created this module say. And we're going to change this from module say to module, I called it utilities over here. I'm going to call this module result. Same name as the file name. That's a very convenient naming convention. I'm going to get rid of this hello thing in here. Now, a couple of things about these this is actually going to be a source code file now that we're going to compile. And we've added this namespace up here and then a module below it. There's a couple different ways you can do module files. The way we're going to do it, you need to put this equals sign there, and then everything under that needs to be indented an appropriate amount. I believe indented in this is set to 4 characters. It is. If you don't have a namespace, if module is the first name in the file, you don't have to have the equals, and you can just left justify everything in the module. We're not going to do it that way. I like namespaces, and because we're going to be integrating this with a C# application, excuse me, with a C# application, we need to namespace it. So we've got our success, or excuse me, our result type here. Let me grab that, and its bind function and its bind, and its bind function and bind operator. There it is. Mouse is a little sensitive. I'm going to copy that, paste it over here into here. And they're not indented properly, so we're getting these little squigglies. That's not a problem. I'm going to press Shift and Alt and go down and do this nifty trick with Visual Studio, creating the alignment line across there, and then tab them in. And that's the beginning of our module. This module, F# Utilities, is now compilable. We can build this, and we can use this result type now from code. We're also going to create another module in this same utilities module that I created here. We're going to create another file. We're going to go add new item. Actually, let's cancel that. Let's go to the result.fs, right click and go add below, because we want it to be below that. That way we won't have to move it. And we're going to add a source file. And we're just going to call this, we'll call this password, because it was password we started working with. So this will be our module for doing our passwords, and we're still going to call it utilities. So let me go grab this namespace over here. Go into here, add this in. Now, remember, we got to put an equal sign after that, and our password stuff's going to go below this. So let's look back at our thing here and see if there's any functions we want to reuse. Well, I think that these basic functions right here, check password, we don't need. We're going to do that a little bit differently when the time comes, but we definitely need these 2 functions. We tested them. They're working. We'll go ahead and use those. Let's copy those out and put them over here in our password module. And again, I need to make sure that they're all properly indented. They didn't quite meet the specs here. So remember, in F#, you've got to indent things. Now, you'll notice a couple of things. Red lines. Red line on success. Red line, I'm not sure why failure didn't give a red line, but it's not defined. because there's it can see a failure in some other thing. So what we have to do is open a couple of things. So one of the things we have to do is open system, and I'm going to put this open system inside the module area here, and there the is null or empty went away. Problem with that taken care of. Now for this other module, we can open result. And now we got our success and failure. The reason we can just open result is because we're in that same namespace. If we weren't in the same namespace, we could apply the entire namespace here and it would open it up. So this should be now compilable. Let's build it again. And build succeeded. So now we've got our password is not null that returns a success or failure, and our password length, min max. These are good initial functions, but there's more to how we have to deal with passwords. And to talk about that, we're going to talk about another type. And I'm going to pull up the requirements document here, and we're going to take a look at it. If I can find it here real quickly. I thought I had opened this up and had it all ready to go, but apparently I accidentally closed the folder that I had opened. That's okay. We can get to it real quickly here. Okay. So this is a PDF file. I'll bring it over here. The website password requirements are down here in this section. This is all open source. Everything in this course is open source. It's under the GNU GPL. This is the actual email verifier we're going to use, and I'm going to show you how to use that when the time comes. Passwords. So what it says here is they must be a configurable number of characters in length, contain no part of the user's name or email address. We're going to leave that part for later. Is neither null or empty. We already did that one. Does not contain white space. We haven't done that yet. Contains at least one, contain at least configurable number of uppercase, lowercase, digits, and special characters. And that all has to be configurable. So we're going to create a record that'll allow the website to pass in the values of these, the min and max length, the minimum number of uppercase, lowercase digits, and special characters into our system to meet these requirements. So let me go to, is it here? And let's copy this. I think that's all of the, yeah, it is. That's all of the password requirements. Let's copy those. We'll close this. And I'm just going to put under password up here at the top, I'm going to put a comment. I'm going to do it like this. Nope. Multiple languages that I work with, right? This is an F# block comment. I'm going to put password requirements so that we have easy access to them. And I'm going to show you something else too. We have been working with, tab that in. We have been working with script files, but we can use the interactive to some degree from writing a source code file as well. We can do the same things. We can take all of this right here, and we can alt paste it in, and the success is not valid. We'd have to load reference the assembly or reference that module differently, I think, or load it in. We could actually do that like this. We can go copy all this in first. Oops. We can go copy all this in. There we go. Then we can go over here to our password file, and we can copy all this in. There we go. And they're in. And then we can use them from there. We can do things with them. We'll probably mostly work on testing things from script files, though. And we've already got our result test, which we did some password testing in. We probably need to make a different script file to do all our password testing. Anyway, This is the beginnings of our password file, and what we need is a record. We need a record to take some things in. So I'm going to take a look at that, and I have a record type here called password rules. I'm going to paste this in, and we're going to take a look at it, and I'm going to explain it. So this is a record type in F#, and I called it password rules. You'll notice a little different configuration for this type. It's surrounded by braces, and inside is a name of a field followed by a colon followed by its type and a semicolon, and each field is separated by semicolons. This record is very compatible with C#. We can fill one in, but I'm actually going to create a little creator, a maker for it, sometimes called a constructor. It's very similar to a constructor in essence. And this function right here, not properly indented, is called create rules. I'm going to roll this down just a little bit. Create rules is a function. This can be called from C#. We can pass in the min length, the max length, the min lower, the min upper, the min digits, the min special. And this is how you build a record from a function. We simply put inside curly braces. Remember that functions always return whatever the last value was, and the last value in this case is a record. And its type inference system recognizes that it's this password rules record because of the fields that we've filled in. And it doesn't take very many. If we just filled in min length, it would recognize it. Because it's the only thing available to it that has that, and it would automatically say, okay, this is a password rules record type. And we're going to take each of these arguments that are passed in and assign them this way to each of the fields and return that record. And so that gets that record back. That's how record type works. Now, we have these functions, and here we're passing in a min max. And here, well, we don't need to pass anything to this. There's a simple rule: is null or empty. We also probably want to check for or test for any spaces that are in it, but we'll get to that. The min max, instead of passing in min max, though, what I really want to do is pass in one of these rules records so that it can just look it up, and we can pass the same record along to multiple functions. And we'll pass that in right here. And we'll just say, we'll call it rules. And instead of min, we're going to say rules dot min length. And we'll say over here, rules dot max length. Now you see it picked it up that time. When I was typing it in over here, I had to type it all out. It didn't show me a drop down that min length was available because the internal system, through its type inference, didn't understand what rules was yet. It now knows that it's password rules because we're calling upon this min length and max length. So now we can pass in the password rules to that and get that min length and max length out of there for testing purposes and match against it and return the appropriate error message. And the other thing I want to do is make a little error message builder out of this. And that's so that we can pass back what the min length and max length should be for that particular operation, so that it's in the actual error. And we'll do that very simply. We'll make a little inner function here for it, and we'll say let error string val equal, and we'll use this built-in sprint f, and the format we're going to use is password length must be greater than %d. Actually, what we'll do is we'll pass in both. We'll make them, we can't use val, min, max, greater than or equal to, or must be less than or equal to, that'll be the min value, and must be less than or equal to, must be greater than, sorry, must be greater than or equal to the mid-length and less than or equal to the %d, which will be the max length. And actually, instead of min and max here, what we could do is pass in rules here. And then we could just do rules dot min length rules dot max length. And now instead of this error message here, we can call error string rules. Put this in parentheses so that it's one call, and we'll just say error rules here. Darn it. Error, excuse me, string rules. And failure, we'll just leave that as can't happen because it can't happen. They can, one of these has to be true, less than, greater than these values. This last position can't ever. It's just there to fulfill our rule, our matching pattern. So let's see if this can work. Let's pass this stuff. I think everything else it needs is already in here. Let's put this and create rules and this all into the interpreter. See if it all compiles. It all compiles in the interpreter, no problem. So the first thing we need to do is create some rules. Let's do this like this. Let my rules equal create rules. Create rules. And what are these requirements now? Min length, max length. So we'll say min length 4, max length 8, and we don't care about the others right now. I think that's all of them, right? 1, 2, 3, 4, 5, 6. Yep. So let's put that into the interpreter, see how it does. So my rules is now that piece. So let's call password length my rules and a password, something like that. Run that. And we see we got the failure. Password length must be greater than 4 and less than 8. Greater than or equal to 4. Let's try it with 4. We got a success. And if it's too long, we still got the failure. Must be greater than or equal to 4, less than or equal to 8. We could separate this out and have two different ones for two different failures on error string, but that's okay. We know that works. So that's a quick way we can test stuff right inside of our module as well. So we've gone over a few things here. We've gone over our record types. We've gone over how to create a record type, and we've actually created one here. I'm going to get rid of this because we don't need it in here. We've remapped our functions now to take in this set of rules and use them properly, so it just gets the rules in. So each function that we develop will get the set of rules, and it'll take out of that set of rules what it needs for that particular function. We developed our own little error string here, so that's pretty good. We're sitting at about 20 minutes on this lecture, and so I think we're going to end it here. We've created a module and put some stuff in it. That module now compiles, and we're well on our way to starting to build up our business rules. In the next lecture, we're going to continue on building out some of these other rules and putting them together, testing them, and learning about some other features of F#. So I want to thank you for listening. I hope you enjoyed the lecture. I hope you got something out of it, and I will see you in the next lecture.